Alright guys, moving on. Number 5, we're looking at two triangles. They're each individual problems, so we're just going to do them one at a time. In fact, I'll just kind of divide the screen in half here. And in each triangle, we're looking for different things. Specifically, number 5, the first one on the left, we're just looking for those two sides, A and B. Okay, so let's talk about how to do this. Like we did for the first 4 problems, I'm going to first ask myself, is it a right triangle? Now, all that's labeled in the triangle right now are the 40 and 35 degree angles. And I know that angles in a triangle should add to 180, so if I take away 40 and also 35 from 180, that tells me that this angle, although it doesn't look it at the top, is 105 degrees. So, is it a right triangle? The answer to that question is no. Okay, so when we try to solve with right triangles, we could use SOHCAHTOA, but if it's not a right triangle, we can't use that. So we go to the next easiest thing on our list of tools that we have in triangles, and the next easiest thing is the law of sines. So let me write it up here, law of sines. The law of sines express that if you took the sine of an angle divided by the side opposite, it would equal the sine of another angle in that triangle divided by the side opposite it. And you're allowed to use this law whenever you have one complete ratio. So what I do when I look at my triangle is I say, do I have an angle and the side opposite that angle? Here I have an angle, I don't know the side. Angle, I don't know the side. Angle, and I know the side. If that happens, then you're allowed to use the law of sines. So we're allowed to use the law of sines here. So to use the law of sines, I'm going to set up that one angle side pair, which in our case is sine 105, and its angle opposite is 10. And all I need to do is use that concept, and I need to use another equation and fill in what I know about the other equation. So let's say I'm talking about this 35 degree angle. The sine of 35 would pair with the letter opposite 35, which is A. Now that I have this ratio, I'm allowed to cross multiply it to help me solve for A. So if I cross multiply, I get 10 sine 35 equals A sine 105. And you'll notice I put the numbers in front of the sine. I do this so that I don't get confused and try to multiply the 10 and the 35, because that would be incorrect. To get A by itself, I need to divide by what's with it, which is the sine of 105. Divide this side by the sine of 105. And that's going to tell me what A equals. I'm going to type it all into my calculator in one go because we don't like to round. So in my calculator, I'm literally typing 10 times sine 35, close my parentheses, divided by sine, and be careful you don't hit cosine like I just did, sine 105. And you get A equals 5.938. All right, that's A. Now I can use the exact same method to solve for B. Technically, since A is 5.938, you can use this pair now. However, I don't like to use the decimals that I came up with, just in case I type the wrong button into my calculator. So I'm going to go with the original pair that I started with, which was the sine of 105 over 10. And now to get B, I need to use the angle opposite B, which is the sine of 40 over B. Same process, we're going to cross multiply. 10 sine 40 equals B sine 105. Divide by sine of 105. Divide by sine of 105. And we get that B equals, I'm going to type it all in my calculator, 10 sine 40, close your parentheses, divided by sine of 105. And we end up that B is 6.654. Alright, this is A and B from the triangle on the left. Now I'm going to try the triangle on the right. So let's look at the triangle on the right. We have no angles. Okay, so it's definitely, we don't know it's a right triangle. And if we have no angles, that means I have no angle and side pair. We don't have any of them. A, B, and C, we definitely don't have the angle and side pair. When that happens, we have to use the law of cosines. And the law of cosines is our last resort. Cosines. It says that if we have a little side, C, and we square it, it will equal A squared plus B squared, A and B both being sides, minus 2 times A times B times the cosine of big C, and that C is the angle that's opposite that's little c. All right, so let's use this in our triangle. I'm going to solve for angle B first, just the one I'm going to go ahead and solve for first. I always like to solve for B, the bigger angle, and since the bigger angle is opposite the biggest side, I'm going to solve for that angle first. So I'm going to fill in everything I know. I know that over here in the equation, little c is the side. So if I want angle B, if I want this to be B, then this has to be angle B right over here. So 43 squared has to equal A squared and B squared. Well, that makes the other two sides. 18 squared plus 37 squared minus 2 times 18 times 37 cosine of B over here on the right-hand side. All right, unfortunately, since the variable is over here, I cannot type the entire thing into my calculator in one go. I have to do things bit by bit. So the first thing I'm going to do is I'm going to find out what 43 squared is. 43 squared in my calculator is 1,849 equals. Now I'm going to find out what these two things added up equal. So I'm going to type 18 squared plus 37 squared in my calculator, and that tells me it's 1,693 minus. Now I'm going to type in all of this in one go. It's 2 times 18 times 37, which is 1,332 cosine of B. All right, so we're looking for this B, and it's all the way over here on the end. Now, I'm going to tell you what the biggest mistake that people make is so that you don't make it. The biggest mistake is that people take these two numbers and subtract them. You cannot subtract those numbers. This 1332 has to multiply by the cosine first, and we can't go around that order of operations. So instead of subtracting those numbers, I'm going to subtract 1693 from both sides. I'm allowed to subtract it because it's not multiplying by anything. That cancels out. And in my calculator now, I've got 1849 minus 1693. That gives me 156. Over here, don't forget the negative. There's negative 1332 cosine of B. Okay. This number is now being multiplied by the cosine of B, and I'm still working at getting B by itself. I can get rid of a number being multiplied by dividing. I'm dividing by 1332. We divide this number by negative 1332. Over on the right, I have cosine of B. Over on the left, I have 156 divided by negative 1332, which is negative 0.117117. It keeps repeating. Great, I'm almost done. I don't want to know what the cosine of B is. I want to know what B is itself. And to get rid of the cosine, I have to do that funny second cosine thing. Cosine negative 1 of this negative 0.1171117, and so on. On my calculator, I'm literally going to type in, I have that answer, second cosine, second ANS. It's next to the enter. It takes that long decimal, plugs it in. That tells me that B equals 96.725 degrees. And that would be angle B. So that gives me angle B. All right, going on a little bit further, okay, and I'm going to make myself a little bit more room down here. We don't just need angle B, we need all the angles. Now that you have the angle B, you have an angle-side combination, and we can go back and use law of sines. If you want to keep using law of cosines for angles A and C, you can, but as you see, it's a lot of work in between. So I'm going to use angle B now, and I'm going to solve for angle A and angle C separately. Okay, let me switch colors here. Angle B being this angle, I have sine of 96.725 over the side opposite, which is 43, equals sine of, let's say I'm solving for angle A first, over what's opposite angle A, which is 37. All right, law of sines is so much easier. We just cross multiply 37 sine of 96.725 equals 43 sine of A. All right, we want to find out angle A. It's stuck to this sine, so we're going to have to do something about that. But first of all, we can get rid of that 43 by dividing. That tells me that the sine of A equals, and I'm going to type all this in my calculator, 37 sine 96.725, close that parentheses after that sine, divided by 43 equals its crazy little decimal, 0.85454, and so on. We don't want the sine of A, we want angle A, and to get rid of that annoying sine part, we have to do the inverse, which is sine -1 of this crazy decimal at 0.85454, and so on. I'm going to use my calculator. I'm going to hit second sine, second answer. It takes that long decimal and does the inverse sine of it. And that will tell me it's 58.709. All right, so far so good. That's angle A, 58.709. Well, now A, B, and C make up a triangle. So angle A plus angle B plus angle C, A plus B plus C have to equal 180. We already know A and B, 58.709 plus angle B, 96.725, that equals 155.434. If I take 180 minus that number, I get angle C is 24.566 degrees.